Hello and welcome to the lecture Generative AI for Vision Tasks Part 1. In this lecture, first we define what do we mean by computer vision. Then we discuss different application of computer vision and try to understand what the challenges we face for different computer vision tasks. Then we try to understand what are the generative AI approaches for this vision task as a very preliminary understanding. For example, we'll discuss image classification problem, object detection, semantic and instance segmentation, image super resolution, image inpainting, etc. As of now, what we have discussed the different deep learning models for different computer vision tasks. We discussed convolutional neural network, which is mainly used for spatial modeling of the vision task, like image classification, object detection, then the different aspects where the spatial modeling is necessary. That means semantic segmentation, etc. Now, in our sequential modeling, where we have learned the recurrent neural network or the improved version, the LSTM, where we can understand different aspect of sequential modeling, where the vision task like video frame level leveling, video analyzing, medical imaging kind of applications. Now here we are now going to understand the different generative model and how this vision task like classification, then object detection, semantic segmentation, then image super resolution, inpainting, and so many things. How the generative models are going to help. But before that, we want to again recapitulate what are the major vision issues that we are going to take into consideration. For example, this slide we have discussed at the very beginning of this course. I repeat it for the continuation of the lecture, that what is a computer vision problem at all? Computer vision problem is basically lies that we make a machine learns how our brain or human brain through this our sensory organ like eye or visually sensory organ like eye that model or that represent a particular image or a visual modalities like image, video, etc. So the interpretation is important. Now what we have said, that very abstract level, it's a color image. Then if you go a bit in details understanding, then we can say this is a human image, then it's a lady, then it's at a very specific term or specific sense, it's a very renowned picture or renowned image of Mona Lisa. Now the similar thing can we do using a camera as our sensory organ like eye, and then we make learn a kind of robotic device or a machine learning model or deep learning model so that it interpret like a human being, so that they can interpret this image at a different level of abstraction. So that is the basic idea of computer vision, basic challenge or basic goal, you can say basic objective of the computer vision. Now you can say what is the major application areas. Now here you can, I note few of them. In reality, lot more are involved, or there is more applications is in practical scenario. For example, face recognition. This is used for security, authentication, unlocking device for this. Here the major objective to recognize the face. Then medical imaging. Now medical imaging, there is a lot of kind of computer vision task involved, from classification, disease diagnosis, then you can say that you can semantic segmentation, and from X-ray, CT, MRI images, is there can detect diseases, kind of disease. So there is a lot of this kind of problem involved or application area exists. Then come the autonomous vehicle that enables vehicles to detect roads, pedestrian, traffic signal, and other vehicles, etc. Then surveillance and security are used to monitor activities and detect this suspicious behavior. Then come object detection, identifies and locate objects in image on videos. Agriculture, manufacturing, optical character recognition is also a very important task that converts printed or handwritten text images in digital text. This is basically for here. Augmented reality. Nowadays, there's a lot of applications where augmented reality are used that recognize objects and environment to place virtual elements. That is augmented reality. And robotics is a huge field where it helps robots to understand and interact with their surroundings. So what we can understand now, the vision task that is quite involved, quite widespread in our daily life. And what is the challenge is that we have to find out the different vision aspects. We have to understand the challenges, and accordingly we have to come up with a more sophisticated model, specifically in the field of generative AI. The major challenges in computer vision include viewpoint variation, scale variation, deformation, occlusion, illumination conditions, that means change of illumination conditions, background clutter, intra-class variation, etc. So these are the common challenges or complex scenarios where vision tasks become complicated. Now we'll discuss one by one these, that these challenges we require to understand so that when we model different tasks, we keep in mind these challenges. Okay, let's start with viewpoint variation. Viewpoint variation is an important challenge in computer vision because an object can look very different when viewed from the different angles or positions. For example, you see that this car image. This car image, when taking image from the front side, it looks this. But if you take same car from a back side, it looks completely different, but the same car. Now, if we do the object detection, your program should understand the this is the same car, even if it been taken in a different viewpoint, and the image is quite different due to these different angular positions. Now here we can see that changes in viewpoint can alter the object shape. Definitely the shape is changed, size, visible features, the perspective, while some parts may become retinal occluded. Now you can see the backlight are not visible in this viewpoint, but this logo is not visible here. So these are the different aspects that we have to take care of. But apart from this, these are two different things. Two same car with different features. For example, a car viewed from a front looks different from the same car viewed from the side. Therefore, computer vision systems need to recognize objects accurately despite these changes. So this is the challenge. Similar in this figure also, that if we take in frontal view, that it looks like something. If we take a side or back view, it looks differently. Even if we have to say, or we have to model our network such that it can detect the same object. Okay, so this is challenge is called viewpoint variation. Next is the scale variation. It is kind of similar, that is a very common challenge in computer vision, because same object can appear different sizes in an image depending on its distance. Just think of this, the camera, which are basically mounted in the road, okay, kind of surveillance camera or CCTV camera, whatever. Now, when a car is very close to the camera, it looks bigger. But when a car in a distance, it looks definitely smaller. Here, viewpoint are same, but it looks differently. Even if with this scale variation, that our model should understand that these two objects are same object. For example, a car may appear large when standing near the camera and very small when far away. This is very simple to understand. This change size can make object detection and recognition difficult. So we have to take care of this. Computer vision system must therefore be recognize object accurately at different scales. So this is called scale variation, and these things we have to take care of when we design our model for different computer vision tasks. Next is object deformities. Now you can see here, this object are basically two objects are same, but it is broken or deformed. So object deformities are a challenge in computer vision, because the shape and appearance object can change when it bends, stretches, moves, changes in posture. Kind of thing. It's a broken image, but it is the same image. Our model should understand it is the same but broken. Now, another example you can say, a person can sit, stand or bend, causing their shape to look very different. These changes make object detection and recognition difficult, definitely. So computer vision system must therefore learn to recognize even when their shape and structure are deformed. So this is called the object deformities, and our model should be invariant with this object deformities. Next is occlusion. This is very important, because in our study we find many a times that our object of interest is somewhat occluded. by some foreground object or other things. So occlusion is a major challenge in computer vision that occurs when one object partially or completely blocks another object from view. So this is the basic idea. Here, a person may be hidden behind another person, or an object may be covered by the vehicle. So this is, you can say, a kind of uh, study of basically the occlusion detection. Now, definitely, occlusion makes the computer vision task very complicated or complex, because without this, maybe some this face recognition, even if this mouth portion is occluded. So that this, how we have to deal with this occlusion problem, is another very important problem of computer vision. Next, the illumination change. As you see in the figure, this is the more or less same figure, but with a different lighting condition. This is more very less light. This is more or less okay. This is something light in a different uh, angle. So if the illumination or lighting condition are changed, then the object detection or face detection kind of problem become very challenging. That what it is been said, that illumination changes are an important challenge in computer vision, because the appearance of an object can change under different lighting conditions. For example, bright sunlight, darkness, shadows, artificial light can affect the color, brightness, and visibility object in an image. The same person may look very different in daylight and low light, as this example is been given. So these changes can make object detection and recognition difficult for computer vision system. Okay. Next come the background clutter. This is also very important. That here you can see the background is such that it's somewhat very similar to the skin color of this fox or wolf kind of creature here. So background clutter is a common challenge, but the background contains many objects, patterns, texture. That means the main object difficult to identify. This is called background clutter. A wolf standing in the forest background with similar texture in its skin and this background. That detect is difficult to detect because background contains many similar colors. So this background clutter can confuse vision system, reduce accuracy of object detection. So these are the basic idea of background clutter, and we have to deal with this background clutter in our different vision task. And then the intra-class variation. So intra-class variation is another very important object, and this is very important in our AI models. Interclass variation means same class. This is the kind of auto classes, and but to look that they are very much different. Is that different kind of same class but different kind? In the computer vision, where object belonging to the same category can have very different appearances. For example, car with different greatly color, shape, size, and design, even though they are belong to the same class. Same as this auto. This variation makes it difficult to computer vision system to identify all objects of the same category. So, therefore, the models need to learn common features that are shared by objects within the same class. So, these are the challenges in computer vision that we have to take care of very judiciously. Now, we are going to understand how generative AI are going to improve the different machine learning or deep learning model for this computer vision tasks. Now, generative AI is a such kind of model that is basically enhance the computer vision problems or the models by enabling models to generate, modify, and understand. So, what the traditional computer vision methods do, that is focus primarily on recognition and classification, what we have seen earlier. But generative AI learns underlying distribution of the images and create a realistic visual content. And this kind of thing, where we can generate some information that is basically very close to a given distribution by means of uh, some samples. Now, what are the popular generative models that we can know? We already know that generative adversarial networks is in short GANs, variational autoencoders, VAEs, diffusion models, vision transformers, and many more integrated with generative frameworks. So these are the things that in this course we're going to address very in depth. Now these models improve the performance of downstream vision tasks by generating high quality synthetic data, that it has a capability of generate synthetic or new data, learning robust feature representation, and supporting the data augmentation. So these things we'll going to understand very in depth in this course. Now, basically, this the different computer vision task, namely image classification, that we have discussed, that how the existing non-generative models are or traditional machine learning or deep learning models works. Now in generative AI, when it comes it creates synthetic data, or it generates the synthetic data to augment training data set, improving the model accuracy and robustness. For object detection, generative models create diverse object variation that helps detector recognize objects under different lighting conditions, viewpoints, occlusion, etc. Now you can understand these challenges now can easily be handled by means of efficient use of generative AI. Now, the semantic or instance segmentation is another important problem of computer vision. Generated images and masks increase training data diversity, leading to more accurate pixel level predictions. So, in this application also, generative AI is very important. Image super resolution employs generative models to reconstruct high resolution image from low resolution, because image super resolution is a kind of process where we predict some new information from low resolution to high resolution. So generative models is very playing a very crucial role here, so that it can create a very similar, so it can easily be used to get a very high resolution image from low resolution image using this generative capability, which valuable in medical imaging, surveillance, and satellite analysis. Now another application, that image in painting, that also to some extent generative part, because some portion is destroyed and some portion we have to restore it. So this restore damage and missing regions image by generating visually consistent content, while image to image translation converts image between different domains, from sketch to RGB, from daylight, day to night, then MRI to CT, etc. So here also generative AI or generative models are very useful. Generative is also extensively used for medical imaging synthesis, produce a realistic medical scan to support diagnosis, address data scarcity, while preserving patient privacy. So that is also because medical imaging, we frequently occur, there is a data scarcity. And if we can generate some very realistic medical image, it will help a lot. Then in anomaly detection, generative models learn distribution of normal images, identify the variation that indicate the defects or abnormalities. So for the different kind of defects abnormalities we can find synthetically. Additionally, 3D scene generation, face synthesis, styles transfer, video generation, these are the domains or these are the computer vision tasks where this generative AI making a very important role, which include the application like entertainment, autonomous driving, robotics, virtual reality, etc. So what we can see that in overall picture, generative AI has become a powerful tool for enhancing downstream computer vision tasks, improving data quality, increasing model robustness, reducing annotation cost, enabling the generation of realistic visual content. So it is a phenomenon that is very important for the vision task. So it's the ability to learn complex image distribution made it a key technology modern computer vision across the healthcare, manufacturing, security, remote industries. So what we can conclude from these discussions that these generative AI now become very important for this kind of vision task. And in this particular course, we try to understand the generative AI models from the vision perspective. Next, we come the different vision task, whatever we have discussed here, that how generative AI going to help to understand it in depth. We'll start our discussion with image classification. As we have understand that image classification is a fundamental computer vision task that automatically assign an input image to one of several predefined categories. For example, here you can see there is a cat image. Our classification task is that it 94% our model said that it's a cat. Other percentage is relatively very small. So that basically said that it is a cat image. So this is the image classification problem. These deep learning models, particularly the convolutional neural network, learn these hierarchical visual features that may be edges, texture, shapes, objects directly from the label training data, as we have discussed before. Now, during inference, the model extracts discriminative features from the image and predicts the most probable class or probable class using a classification layer. Typically follow a softmax activation function. So what actually we are doing is the two basic part of this kind of convolution neural network. Convolution neural network in general non-generative. It first automatically extract the features like edges, texture, shapes, object directly from the labeled examples, and then this after extracting this discriminative feature, they try to use some sort of fully connected network or something like that as a inference network or classification network to find the most probable class based on these discriminative features, and then they use a softmax to find these percentages. Now this is as a whole the image classification, and normal deep learning is basically going to handle this problem in this way. Now, how generative AI put more value in this kind of image classification problem? So, generative AI or Gen AI emerged as a powerful approach of image classification by learning complex data distribution and generating realistic representation that improve model performance. Now, first, what we have discussed that in general, in supervised deep learning based classification problem. There we required a high number of or huge number of leveled example, which is in general very costly and time consuming to get. Here, these generative models easily generate the synthetic images or labeled examples so that can be used as a very easy solution for this purpose. So, generative AI, by virtue of generating the synthetic image, helps a lot to supply or to arrange the huge number of training data, labeled training data for the supervised based CNN-based classification. Now, as we already know that the models include the generative model, this generative adversarial network, variation autoencoder, diffusion model, etc., can synthesize new training sets, helping to overcome challenges such as limited dataset, class imbalance, and noisy dataset. What we have said. These synthetic images enhance data augmentation, enabling classifier to achieve higher accuracy and better generalization. That is very understood because this synthetic data, new data, it is not that it is a reconstruction of the existing data. It is a new data, but following the given distribution or this labeled distribution, labeled samples. Definitely, if number of labeled sample is becoming high, it helps classify to achieve higher accuracy and better generalization. So in image classification task, generative AI can also perform feature learning by extracting meaningful Latin representation that improve recognition of object, face, medical imaging, remote sensing data. This is also a very important point that when you understand that how a VAE model is working, we'll see in our subsequent lectures that it will create a latent space, or better to say a latent distributions, and from this distribution we samples to generate the new images or new data. Now this latent space is very important for generating data. So generative AI, this feature learning, it try to understand the inherent distribution of the given data or sample data and try to find the distribution, and by this distribution they basically try to this latent space or latent distributions. So it performs feature learning by extracting meaningful latent representation that improve recognition of object, faces, medical imaging. This is the one of the another important aspect. Furthermore, generative model supports semi-supervised and unsupervised learning, that reducing the dependency on large level dataset. That is one of the important factor because generative model in general unsupervised, or you can say semi-supervised. Recent advancement integrate generative AI with deep convolutional networks and transformer-based architecture, resulting in robust classification system capable of handling complex real-world scenarios. That we'll see in our transformer-based approaches. How CNN-like architecture, when they put in a kind of transformer setup, it will help this kind of image classification task more accurately. Consequently, generative AI becomes an essential component of modern computer vision, significantly enhancing the efficiency, accuracy, reliability, classification application across healthcare, autonomous driving, agriculture, and many more. So that is important. Why we are putting this in effort? But you have to understand there is a standard literature on image classification problem using this CNN-based architecture. But now we have to understand how generative AI is going to help over the normal CNN architecture by synthetically generate the new data. Our next task is object detection. Object detection is a computer vision task that identifies both the location and the class of one or more objects within an image. So give it this image. This is a training image, and what we see, there is a different objects. So let's consider one object, like a dog here. So what is the basic output of this object detection task? There is a two output. One is what is the object and where is the object. That means localization. For example, it is a dog image. So, and this is the bounding box given the portion of the total image, that this is the, here it is localized. Now here you could see, unlike image classification, which assign a single label to entire image, object detection predicts the bounding boxes around objects along with their corresponding class labels and confidence scores. So that's why it is object detection. Now what are the available method at this moment for object detection? YOLO, faster RCNN, SST. We basically learn this by learning the robust spatial and semantic features for annotated dataset, and it enables then the real-time and accurate detection in complex scenes. And this is the, as already discussed, this is the object detection. To understand these two things, the output object detection is twofold. One is classification score and is what is the localization. This is the actually bounding box, they will give the coordinates. Okay. Now we have to understand how generative AI help, but the conventional tools what is been present at YOLO, SST, etc. The generative AI is improving object detection by helping computers identify and locate objects in image and videos more accurately. How? The traditional object detection models need a large amount level training data, which is expensive and time consuming. So here also, like image classification problem, it creates a synthetic data which increase or had more annotated training example and make this existing model more accurate. Now, the generative models like GAN and diffusion models can create realistic synthetic images, the size and variety of traits. That is definitely. Now, these additional images help object detection models like YOLO, FastR, CNN, SST to learn and recognize the objects under different conditions, including poor lighting, different backgrounds, and partial occlusions. Now, one thing you have to understand that getting the suitable images for training images, annotated training images, with these attributes like poor lighting, different backgrounds, partial occlusions is not always very easy. But if we can generate these scenarios or these attributes synthetically, then we can get very easily these scenarios and plenty of images like this. And generative AI helps of this object detection problem in this particular test. Now I have to understand how it basically works. Generative AI also supports data augmentation and image enhancement, making detection system more accurate and reliable. As a result, you can see here on the noise and latent code, we can say get this generator, we can get the object patch or kind of this real and object patch. This is real object patch. So there is a discriminator kind of thing that you can make this more realistic. And this is the target image. So this is a very naive design or naive architecture. We'll see later in a very detailed formulation. So as a result, object detection models become more robust, require less manual data collection, and perform better in real-world applications such as autonomous vehicle, medical imaging, security surveillance, robotics, and smart manufacturing, and so on things. This is the kind of way of object recognition. Now, one thing that we have to understand here, this is a generated part by from starting from a noise and some Latin code. They generate some image, and this is a real object patch. This discriminator find what is the difference, and this way this generator is being trained again, so we can get the more realistic image by this way. Repeatedly training this will get. This is the object. Next topic is semantic and instance segmentation. A semantic segmentation assign a class level to vary every pixel in an image, grouping all pixels of the same category together without distinguish individual objects. This is instance segmentation. On the other hand, goes further by identifying and separating each individual object within the same class, enabling precise objective differentiation. Okay, while semantic segmentation provides overall scene understanding, instance segmentation offers more detailed information by distinguishing separate objects. That is the basic difference between semantic and instance segmentation. Both tasks are widely used in computer vision applications in autonomous driving, medical imaging, or have significantly improved by modern deep learning models like FCN, UNet, DeepLab, and Mascars. So this is as a whole the idea of semantic and instance segmentation. And you can get a diagram here. So this is the original image. Semantic segmentation, you can see that these are humans, so they are semantically similar. So you can see this just pixel wise, every pixels of human is mean. This is semantic segmentation. But here, instance segmentation, that every human is not only selected, they are precisely said these are the different humans. So this is the instance object. Okay, so this is called instance segmentation. Now I have to understand how generative AI help in this semantic and instance segmentation. So that Gen AI emerged as a promising paradigm for enhancing semantic and instance segmentation by leveraging the powerful generative models like GAN, differentiation to improve the feature representation, data synthesis, and segmentation. Unlike the conventional discriminative approaches that directly predict pixel-wise levels, Gen AI basically use the generative adversarial network, British autoencoders, diffusion models, and transformer generative architectures. Learn the underlying distribution of the visual data, and that is very important. Generative model, the main capability or main advantage coming from this, it try to understand the underlying distribution of visual data to generate the realistic images, define segmentation mask, and produce high quality synthetic training. In semantic segmentation, generative models facilitate the domain adaptation, image-to-image translation, data augmentation, thereby improving the model robustness under limited level data and varying environmental conditions. So, as a whole, we understand the generative AI is very helpful for this kind of downstream vision tasks like semantic segmentation or instance segmentation. For instance, segmentation, these models enhance object boundary definition, recover occluded object regions, and generate instance aware representation that improve the separation of the overall objects. Vision language foundation models and prompt-driven segmentation framework, such as segmentation anything models and diffusion-based segmentation methods, further demonstrate the capability of generative AI to perform erosion and fusion segmentation with minimal task specifics. These are the more emerging methods. Now, by combining this generative model with large-scale pre-training and self-supervised AI significantly improves the segmentation performance, adaptability across the diverse application domains, medical imaging, autonomous driving, remote sensing industries. Our next topic is image super resolution. Image super resolution is a computer vision task that reconstructs high-resolution images from low-resolution inputs by recovering lost spatial details. Now, mathematically, it is a hill-post problem because what is essential here? Let's say there is a 8 by 8 images and we need to reconstruct a 16 cross 16 images from this 8 cross 8. So we require to have more information which is available in input. So in this case, it is in general generative in nature. So in image super resolution is a very important task or important computer vision task where generative AI can contribute a lot. The traditional methods such as interpolation, example-based approaches often produce blurred results with limited detail distribution. Now recent learning-based approaches, mainly deep learning, including CNN, transformers, and some generative models like SRCNN, EDSR, ESR-GAN, SWIN-IR, these are significantly improve the performance by learning complex mapping between low and high resolution images, producing more realistic and detailed output. We'll see some examples later. Now let us try to understand how generative AI enhance this super resolution process. Generative AI further enhance the super resolution process by synthesizing missing texture and improving visual fidelity. An image super resolution is widely used for applications such as medical imaging, remote sensing, autonomous driving, surveillance, digital photography. But high quality images are essential for accurate analysis. In this figure, you can see the low resolution. There is some sort of checkerboard effects or some blurry effects there, but it's a very high resolution image. So from this input, now how generative AI helps? Generative is in significantly advanced in super resolution by enabling reconstruction of high resolution images with enhanced visual quality, realistic texture, and fine structural details from low resolution images. What it primarily do, we try to understand the underlying distribution, accordingly reconstruct or synthesize the new patch or new part of the image. Unlike conventional interpolation or discriminated deep learning methods that primarily optimize pixel-wise reconstruction, generative models learn the underlying distribution of the image to synthesize plausible high-frequency details that are often missing in the degraded image. The technique based on GAN diffusion models, transformers generative architecture, demonstrate remarkable performance in producing the perceptually realistic images while preserving the semantic consistency. Now, some models like ESR-GAN, VLASR-GAN, stable diffusion-based super resolution frameworks, and latent diffusion models effectively reduce blur, surface artifacts, and recover complex texture under challenging imaging conditions. So, in this way, generative AI helps in super resolution. Furthermore, foundation models trained on large-scale datasets exhibit strong generalization capabilities, enabling robust super resolution across diverse domains. And you can see here, generative AI-based super resolution has found widespread application in medical imaging, satellite and remote sensing, surveillance, autonomous driving, digital photography, video restoration, scientific imaging, and cultural heritage solution. But enhanced image quality is essential for accurate analysis, interpolation, and decision making. So, what do you understand that is generative AI, by virtue of its generative nature, give a big advantage or big improvement in the immersive resolution. Our next topic is image imprinting. So image imprinting is a computer vision technique that reconstructs missing or damaged or unwanted regions of an image by generating visually realistic content that seamlessly blend with the surrounding pixels. The primary objective to preserve the structural detail, textural consistency, and semantic information while restoring the image. It's a kind of restoration technique where if some old image is being destroyed due to some noise, we try to reconstruct the missing or damaged part of the image. Traditional imprinting methods rely on diffusion and patch-based algorithms, which performs well for small missing regions but often fail to reconstruct the complex scenes. Here are some examples of image imprinting. There is some problem with these images. So modern deep learning approaches, particularly those based on the CNN, transformer and generative AI models such as generative adversarial network diffusion models, have significantly improved the imprinting performance by learning contextual and semantic representation of the large dataset. That is very important. These models can generate high quality photorealistic content even for large missing areas, making image imprinting an essential technology in image restoration, object removal, photo editing, medical imaging, cultural heritage preservation, and augmented reality. So this is the way the generative AI basically helps in image imprinting. Now, how it basically helps? Generative AI has transformed the image by enabling the realistic reconstruction of missing damaged regions of image using semantic and contextual information. Unlike traditional diffusion and patch-based methods, generative models learn underlying distribution of visual data, synthesize coherent structure, texture, and object details that seamlessly integrate with the surrounding content. Advanced artificial generative diffusion model transformer that effectively restore the large missing areas object and preserve both local texture and global scene consistency. So basically, this generative AI a lot of improvement in image imprinting from the simple CNN based models. Recent approaches, including stable diffusion-based imprinting and transformer-guided models, achieve high-quality photorealistic image completion that you can see here. The original image, the synthetic image from the new object. And here you can see the original image, this part is just gone here. So original image object removed. Synthetic image is new object, varying object position or detection. So this is done by the image imprinting. So as a result, generative AI-based image imprinting has become a key technology in image restoration, photo editing, film and video post-production, medical imaging, cultural heritage preservation, sensing, and augmented reality, right? Accurate and visually possible image reconstruction. So that is the nature idea of how generative AI that helps in image imprinting. So in this lecture, we first define what is computer vision, then we understand what is the application of computer vision. Then we describe different challenges of computer vision, and then we try to understand how generative AI improve the vision task in different vision downstream tasks for image classification, object detection, semantic and instance segmentation, image super resolution, image imprinting. In the next lecture, we continue this with another few downstream vision tasks. Thank you very much.